This video is a summary of the Edexcel Further Mechanics 1 book, Chapter 1, Part 1, Momentum in One Direction. Imagine a car and a truck driving along a road. Imagine they were to get out of control and accidentally crash into a house. Which vehicle do you think would cause more damage? I think it would be the truck. Now imagine two cars, same in every respect, travelling towards the same house, but this time imagine one of the cars was going much quicker than the other. In the same way, if they lost control and crashed, which car do you think would cause more damage? I think it would be the quicker car. And this is exactly how I like to think of momentum. So the bigger truck wins because it's got more mass. So the formula for momentum is going to be something to do with mass. And the quicker car wins because it's got more velocity. And in fact, the formula is simply timesing these two quantities together. Mass times velocity. Even though it's momentum, we give it the letter P. That's because m has been taken up with mass. So P is momentum equals mass times velocity. In case you're interested why P, it comes from the Latin pellere, which means to push. Now mass is measured in kilograms, and velocity is measured in meters per second. So when we combine these two together, the unit for momentum is Newton seconds. Finally, you need to know that if you've got two momentums or two momenta, you can either consider them as a whole system and consider their combined mass, or you can consider them separately and add their two momentums together. Impulse is probably used less often than momentum in day-to-day life, so it can be a bit harder to understand. The formula that we need to know is that it's the change in momentum. In other words, it's mv, which is the end momentum, subtract mu, which is the starting momentum. Another formula is F times T, but that's less useful. We're going to use the top formula a lot more often. For those interested, here is a proof of the equivalence of the two impulse formulas. For those allergic to proofs, you might want to look away now. So we know from the definition that it's mv minus mu, it's the change in momentums. And of course, they've both got m in, so we can factor out the m like this. Now we know that Newton's second law says F is equal to ma, so with a bit of a rejig, we can say that m is equal to F over a, F divided by a. If we pop that into the left-hand side, we get F over a multiplied by v minus u. Now with a little more of a rejig, we can move the a across to get v minus u over a. Structurally the same, but now you might recognize this if you've done Suvat equations already. So this is a rearrangement of v equals u plus at. So v minus u over a is exactly the same as t. And that gives us our final answer. F times t is impulse. Although the mv minus mu formula is more useful, force times time is actually quite nice to represent in real life. You might say hit a tennis ball. You are hitting it with a force for a very short amount of time, and that is what impulse represents. It's important to know that impulse inherently has a direction. If the black ball was hit towards the orange ball, then the impulse exerted on the orange ball from the black ball would be directed to the right. Conversely, the impulse exerted on the black ball by the orange ball would be directed to the left. Fortunately for us, due to Newton's laws, these two impulses have the same magnitude, they just act in opposite directions. Similarly, if you were to drop a ball and it hits the ground, the impulse exerted on the floor by the ball acts down, and the impulse exerted on the ball by the floor acts upwards, again by the power of Newton. These two impulses are the same with opposite signs. The last thing to note is that given that it's the change in momentum, and that we know from before momentum has the unit of Newton seconds, then the combined unit of impulse is also Newton seconds. Here are the key takeaways. Now it's time to revise this with the examples video and the past paper questions.